This video is going to be about the continuity equation. The continuity equation simply states that if I take a pipe and I put one volume in to the left side, the same volume has to come out the right side. This means that if the speed of the fluid flowing into the pipe is V, and the pipe has a cross-sectional area A, and the length of the beginning of the pipe from this point to this point is the speed times the time, I can write an equation for the volume of this section of pipe, the area at the beginning, 1, times the speed at the beginning, 1, times the time the fluid takes to flow from one point to the point that I'm considering, is the volume of that section of pipe. I can do the same for the right-hand section of my pipe, and since it's got a cross-sectional area of A2 at the end of the pipe, it's got a speed of V2, and it's got a time that a fluid takes to flow from one section that I'm interested in to the next. So if we kept the time the same, that drops out, and we see that the cross-sectional area times the speed of the water entering the pipe equals the cross-sectional area and the speed of the water leaving the pipe. So what does this equation mean for a pipe that isn't just the same diameter throughout? What if we have a pipe that starts wide and narrows just like this? The cross-sectional area at the beginning is bigger than the cross-sectional area at the end, A2. The water entering the pipe will have speed V1, and the water exiting the pipe will have speed V2. When we write out the continuity equation, A1 V1 is equal to A2 V2, we see that because these have to equal each other, and one has a big area and one has a small area, that means the part of the pipe that has a big area must have a lower speed or a slower speed, and the pipe that has a smaller area must have a faster speed, so that these two quantities equal each other. These two expressions equal each other. That's the end.